Okay, let's practice some more of Charles's laws. Just as a reminder, Charles's law was a relationship between a direct relationship between volume and temperature. V1 divided by D1 equals V1 divided by T1, V2 divided by T2. And so as temperature increases, then volume would increase. If temperature decreases, volume would decrease. And we sort of talked about how this is usually a flexible container that can actually change volume. And so if I take a balloon outside in the hot air, that balloon, the particles inside would start moving faster and faster and faster, and that balloon would increase in size. And so it's a direct relationship. All right, so again, do not forget on all of these where we are given Celsius, which you'll see in just a second, we're always going to add 273 to convert it to Kelvin. So number one, a sample of nitrogen occupies a volume of 250 milliliters. And again, that's okay, just like we talked about on the last video, last lesson. It's okay to have it in milliliters as long as both your volumes are milliliters. And so if the other one is the one that's unknown, your answer then would be in milliliters. So a sample of nitrogen occupies a volume of 250 milliliters at this temperature, 25 degrees Celsius. So these two go together. I just need to make sure I convert 25 degrees Celsius into Kelvin. And I do that by adding 273. So 25 plus 273 would give me 298 Kelvin. So that is actually going to be my T1, and this is my V1. What volume? So here's my what word, and so there's my unknown volume. What volume will occupy it at my T2, 95 degrees Celsius, and again I add 273 to that, and that would give me 368 Kelvin. Okay, and so now I can just take all of those pieces and plug them into my equation. So V1 over T1 equals V2 over T2 is my formula. So now I'm just going to plug in to that formula. So what's my V1? 250 milliliters. My T1, by adding 273 to that 25, 298 Kelvin. V2 is my unknown. It's what the question was asking me. What volume will it occupy at 95? So here's my T2, which is 368 Kelvin. And as we said yesterday, the easiest way to solve these problems is to cross multiply and divide. And so with our calculator, we would cross multiply these two. So 250 times 368 equals, okay? And once I've done that, I can divide by that one. So divided by 298 gives me 308.7. Now, if I went back, I could look, about three significant figures is what we're going to use there. What I did my calculator, 250 times 368, and I can see here if I put my units on these and then divide by 298 Kelvin, that my Kelvin cancels. And so I get my volume 2 as 309 milliliters. And box the answer. Okay. Second problem. Okay, oxygen is at 40 degrees Celsius when it occupies a volume of 2.3 liters. So here's my T1. The volume occupies this volume. So these two are together. And so they're T1 and V1. The only thing I need to do to this is add my 273. And if I do that, I'm going to get 313 Kelvin. Okay. All right, what should be the temperature at this volume? And so we can see what's happening to my volume. It's going from 2.3 liters to 6.5 liters, so it's increasing. So we should see an increase in temperature because of that direct relationship. So V1 over T1 equals V2 over T2. So I'm going to say volume 1, 2.3 liters, divided by 313 Kelvin equals V2. V2 is 6.5 liters divided by, now the missing, which would be T2. So it says, what should the temperature be? That was my unknown. Okay. And so what are we going to do? We're going to do the same thing we've done on the other ones where we cross multiply and divide. 313 times 6.5 equals, divided by 2.3 equals. So 884.5 would be about 885. Although this one really probably should only have two significant figures from my question. So we could round up to 880 Kelvin equals T2. And so did my liters went up, my volume increased, so then also likewise my temperature increased. And so you can visually see now that this was a direct relationship. One more, and then you can work some of these problems on your own on today's quiz. Hydrogen gas was cooled from, now they're giving me two temperatures right together. So we're going to have to figure out which one of those temperatures this volume belongs to. So let's go ahead and make sure we first of all convert these to Kelvin, and then we'll just identify one as T1 and the other as T2, this being T1 since it's going from this temperature to this. So hydrogen gas cools from my T1 to my T2. Okay, and so on each one of those, I'm going to be adding 273 in order to get my new temperature. So I can go 150 plus 273, and that gives me 423. And of course, 50 plus 273 gives me 323 Kelvin. Okay, there's my temperatures. All right, now let's look at the volume it gives us. It says its new volume is 75. So by them saying that it's the new volume, it must be what it was cooled to, the T2. So this must be the V2 then. And then it asks, what is that original volume? What was the volume originally? V1. So V1 over T1, again, just rewriting this formula as many times as we can, helps us to remember it. So it's really comes more naturally for us, which is why so much practice is important. V1 is the missing. T1, 423 Kelvin, equals V2, 75 milliliters, over T2, which is 323 Kelvin. Okay, so right away we should go ahead and kind of make sure our answer is right. We look like we're doing a decrease, right? A decrease in temperature from original to new. And so really my V1 should be a higher volume because it should be decreasing also in volume. Let's check it out. So we're going to cross multiply and divide. So we're in our calculator, 423 Kelvin times 75 milliliters. And then we'll divide by 323 to get the V1. So 423 times 75 divided by 323 gives me a V1 of 98. And if I cancel my units, it's going to be milliliters. Okay, so take some time and go and check some of these out on the quiz for today.